Human beings have been engineering, manipulating biology for over 10,000 years, since our ancestors began with the domestication of plants and animals. But over the last 50 years, we've been doing that on a molecular level. They used to call that recombinant DNA, and now it's called genome editing and genetic engineering. This has profound implications for how we think about not just healthcare, but plant and animal agriculture, advanced materials, energy, DNA, data storage, and so many other things. I know the idea of manipulating biology is frightening for people, but this is something that we've been doing for a very, very long time. And the question is, how can we do this as wisely as possible for the benefit of all people and of humanity? When most people think about the genetics and biotechnology revolutions, they tend to think about healthcare, and for some very good reasons. Many of us have the COVID mRNA vaccines inside of us, and that's helped many people across the globe. But although the genetics revolution is bigger than healthcare, it has very profound implications for healthcare itself. Not just vaccines, but we're seeing a transition from what I call generalized medicine, generalized healthcare based on population averages, to precision and predictive healthcare based on each person's individual biologies. And that's opening the door to incredible new treatments, including gene therapies that can target specific mutations in a person's genome that are causing terrible disease outcomes. Including mRNA treatments not just for COVID-19, but personalized cancer vaccines, personalized cancer treatments based on the individual molecular identity of each person's cancer. The implications of the genetics and biotechnology revolutions for healthcare are profound, but they are equally profound, if not more so, for many other areas that are really important to not just human life on Earth, but to life on Earth. We live in a world where there are 8 billion and soon to be 10 billion humans because of the advances we've seen in agriculture, particularly over the past 100 years, with the modern ways of creating fertilizer, with the revolutions in agriculture like the Green Revolution. But as the number of humans increases and the demands of humans for higher quality food increases, we can't just do agriculture in the future the way that we've done it in the past. We really need to think about how do we make our agriculture both more productive and less resource intensive. And the tools of the genetics and biotechnology revolutions will help us do exactly that through thinking differently about fertilizers rather than using the traditional chemical fertilizers, thinking about manipulating soil microbiomes to help plants grow, thinking about different breeds of plants that can have greater yields and also help address issues like climate change. None of us, if we were dropped on a desert island, could replicate all of civilization on our own. Our cultural inheritance is as important as our genetic inheritance. And so we need to be able to record that in new ways. We are bumping into limits of what the current generation of silicon computer chips can store. But we know that DNA is the greatest information storage mechanism in history. It's 1 billion times denser than silicon. We know that DNA in the right conditions can store data for millions of years rather than just decades for silicon. So there are billions of dollars of investment going into DNA as a data storage mechanism. The opportunities for using the tools of genetics and biotechnology to build a safer, better, more sustainable future are profound. In many ways, if the 19th century was the century of chemistry and the 20th century was the century of physics, the 21st century is and will be the century of biology, where we humans will use the tools to engineer biology in order to build the kind of safer and more sustainable world that we would all like to inhabit.